Let me start with the class. Okay. Good morning, everyone. Class one. Yeah, can you able to see the screen now?
Yes, sir.
Yeah, okay, right. So good morning. Sorry for the interruption. So let's start with the next chapter. Now I'll move on to the module 5. The last module, we have two chapters there. One is additive manufacturing system, and the other one is going to be what is called as your the industry 4.0. Now let's start with the additive manufacturing system, basically. Now, probably you might have heard of this additive manufacturing system in many of the instances. Now, this chapter is mainly dealing about the concept of additive manufacturing system, the different processes of additive manufacturing system, and what are the advantages, disadvantages, and the applications of additive manufacturing system. Okay, right. Now, before we proceed further, now we'll try to clarify some of the important things regarding the additive manufacturing concept. Now, when we go to the additive manufacturing processes, now there are some points or some the names which are going to be synonymously used. Okay, so we generally call it as what is called rapid prototyping. Then we largely call it as 3D printing. Okay, now let's first understand basically the additive manufacturing is a word, okay, which is going to be synonymously used with what is called the rapid prototyping. Just because that, why we are going to call it as rapid prototyping is simple, that in case of your rapid prototyping, basically before you are going to manufacture the work parts, okay, please understand, before you are going to manufacture the work part, you want some look like of a manufactured part, okay, to be made before, okay, so that you are going to check the functionality on that. Okay, now because what is going to happen if you are going to produce the component, okay, if you are going to produce the component directly, if some problems are going to occur, the whole of the manufacturing cost is going to be wasted. Therefore, rather than directly manufacturing, what is that we are trying to do is we are trying to make sure, okay, that we'll be having what is called as a, okay, we'll be having what is called as a technique by which we are going to do the prototyping. Okay, now prototyping is a process. Prototyping is a process of having a look like of a material. Okay, that is what is the basic meaning. And the fastness with which we are going to do is very larger. Okay, so that is the reason why we call it as the rapid prototyping. Okay, right. So have you heard of rapid prototyping earlier? Yes, no, right? Have you heard of RPT? Have you heard of RPT earlier? Hello?
Yes, sir.
Are you aware of RPT? Right. Right. If you're aware of RPT, okay, it's fine. Okay, we'll just proceed. Now, in the case of your the rapid prototyping technology, so the thing is this, what we have just now discussed. Now, the question now is, now as I said, okay, as I said earlier, the work parts are going to be produced, okay, before you are going to manufacture. Okay, that is why we call that terminology as rapid prototyping. But nowadays, what has happened is we are not going to use, okay, nowadays we are going to use this rapid prototyping methodology for producing the components itself. Okay, as we are going to use this for producing the component itself, we are going to replace the rapid prototyping by using what is called as the additive manufacturing. Okay, means to say that Now, rather than calling it as a prototyping is what? Prototyping is something which you are going to produce before you manufacture. But nowadays, rather than you are going to use this technology for prototyping purpose, you are actually using it to produce the main material itself, okay, main component itself. That's why this rapid prototyping word has now replaced by what is called the additive manufacturing. Okay, now that is how the word which has come as additive manufacturing. Now, before we just understand about the other details, quickly we'll understand what is this additive all about. Okay, now till now we heard something called a subtractive manufacturing. Okay, subtractive manufacturing in a sense, some manufacturing processes you have come across. Okay, you have done manufacturing process by using the lathe, by using milling machine, by using turning machine, or by using slotting. Okay, all the way that you have used it in all the material. Okay, in all the processes, what you have done is you have tried to remove the material. Okay, you have tried to remove the material in order to convert from raw material into the useful product. Okay, so that is the concept of what is called as subtractive manufacturing, wherein in order to get the work part, you are going to remove the material from the raw material. Okay, that is subtractive. Now, a new technology which has come now is what is called as additive manufacturing. Now, in additive manufacturing, what you are going to do is you are going to add the parts. Okay, you are going, not the part, let us say, you are going to add the material layer by layer. Okay, now this technology is called as a layer technology. Okay, means you are going to add the material layer by layer. Okay, so that in order to build up a work part. Okay, as you are going to add the material layer by layer, this technology is prominently termed it as the additive manufacturing. That's how this additive word has come into picture. Okay, right. Now, this is the basic understanding of what is called as the additive manufacturing all about. Okay, right. Now, let's just go with the thing. So, what is there is additive manufacturing processes, which are also known as rapid prototyping, refer to an evolutionary type of fabrication that utilize a three-dimensional CAD file and slice it to different thicknesses. Okay, this is very, very, very important. Okay. So, first thing is, what is the starting? Okay, what is the starting of your additive manufacturing? Is the CAD file, okay, three-dimensional CAD file. Like in your subtractive manufacturing, what is the starting raw material? The starting material is the raw material. Okay, from the raw material, you are going to get the finished product. But in case of additive manufacturing, the raw material is going to be raw material in the sense the starting is going to be what is called as a 3D, three-dimensional CAD data, okay, of a work part that you want to manufacture. Okay, so that is going to be the beginning. Okay, so this is a greater amount of fabrication method. Now, it is commonly known as 3D printing. Okay, now in the consumer market, okay, in the consumer market, we generally use the word what is called as 3D printing rather than what is called as the additive manufacturing. Okay, additive manufacturing is the company side people are going to use. In the consumer market, generally we use it the word called as 3D printing. Okay, right. Now, next point you just observe. A computer uses what is called as, okay, right. The computer uses the sliced files. Okay, this is very important. Computer uses sliced files as geometry of each layer and orders the fabrication setup to deposit a layer regarding that geometry. Okay, now this is very important. Now just understand. I'll just explain here, sir. Right. Now, what is that you are going to make is you have what? You have a 3D CAD file with you. Okay. So this 3D CAD file, you are going to convert that into sliced file. A sliced file is nothing but now if you just observe, this is going to be your CAD file, just a simple thing. Okay, what I am going to do, I am going to slice this something like this. Okay, I am going to slice this depending upon the thickness. Okay, now as per the thickness, I am going to slice this. Now I am going to consider one slice. Okay, first slice. Okay, second slice, third, fourth slice. Okay, now through the nozzle of the machine, I am going to keep on. Okay, I am going to keep on press this amount of layer first. Okay, first this layer has come into picture. Okay, then next one more layer is going to come into picture. Then one more layer comes into picture. Okay, like that, I'll keep on what? I'll keep on depositing the material layer by layer. Okay, by which I am going to build the work part. Okay, now what is that I am adding now? I am adding the material like this. Okay, just to mention. Okay, just to understand that I am drawing like this. Okay, now by adding the material, you are going to get the replica of the product. Okay, right. Now the layer by layer deposition. Okay, now this is very important. This layer by layer deposition continues to the last layer in order to fabricate a complete 3D component. Okay, now as I said, this deposition is going to continue till you are going to get the complete 3D component. Okay. So now in order to do this, there are various different methods which are going to be available. So as we proceed further in this this particular chapter, we are going to understand what are the different types of the processes that we are going to use later. Okay. So as of now, we just understand that additive manufacturing is something which is called as your rapid prototyping, right? Rapid prototyping, wherein I'm going to use the 3D CAD file. Okay, we are going to use a 3D CAD file, and we are going to carry out the operation. This is also called the 3D printing. Okay, right. Next, we just observe. Okay, we'll go with the formal the definition. Okay, universally accepted definition of 3D additive manufacturing. Right now, this is how it is going to be. Additive manufacturing is defined as a process by which digital 3D design data, okay, digital 3D design data is used to build up a component in layers by depositing material. Okay, so this is the definition, okay, as given by ASTM, okay, American Society of Testing and Material. Okay, this is the standardized body as defined. Okay, universally defined definition of additive manufacturing is that additive manufacturing is defined as a process. It's a process by which digital 3D design data. Okay, so you have what data? You have a 3D data. Okay, 3D design data is used to build up a component. Is used to build up a component in layers by depositing material. Okay, now so starting should be what? You should have a CAD file. That CAD file you are going to convert that into a STL file. I'll explain that later. CAD file will be there, converted into STL file. STL file is the layered file that you give it to the machine. What machine is going to do? Machine is going to build, okay, the component by depositing the material layer by layer. Okay, one layer, another layer, like that. A layer is something but represented by a thickness. Okay, so the thickness of the material will keep on deposited. Okay, so that is the basic definition of what is called as additive manufacturing. Now, it also going to be represented as, okay, the term additive manufacturing includes subset like, okay, these are the other names of additive manufacturing, that is 3D printing, rapid prototyping, direct digital manufacturing, and layered manufacturing, okay, and additive fabrication. Okay, these are all the different names given for what is called as additive manufacturing. Okay, right. Now the application of additive manufacturing is enormous actually. Okay, now it is generally used in all the varieties, okay, all the varieties of the component, okay, right from the aircraft, dental or medical industry, medical implantation, automobile, and in the jewelry industries, this additive manufacturing is largely used. Okay, right. Now again, I am just bringing here, because the term 3D printing is increasingly used as a synonym for AM. However, the latter is more accurate in that it describes a professional production technique which is clearly distinguished from conventional methods of material removal. Okay, now why we call it as the additive manufacturing is, okay, why we call it as additive manufacturing is because it clearly distinguished from conventional methods of material removal. Okay, now what we know, conventional methods of material removal is what? Is the subtractive manufacturing. Okay, now in order to make it very clear, okay, to the audience, okay, now they have used the word called as additive manufacturing, because the word itself is additive manufacturing means you are adding something, in order to produce the component. Okay, that is why the additive manufacturing is very much largely used in the industries, and as we generally as a consumer, we are preferred to use what is called as 3D printing. Okay, right. Now before we go further, okay, we'll just understand, okay, now how this okay, right, how this is go, how the additive manufacturing is going to be. Okay, right. Okay, now if you just observe, okay, now I just have a small video, okay, which shows about this. Okay, can you able to see the video?
What is additive manufacturing?
Can you able to see the video?
Additive manufacturing, also known as 3D
Yes, sir.
Yes, sir.
Yes, sir.
Yeah,
is a process that creates a
please.
physical object from a digital design. An engineer designs the object using computer-aided design, or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the first layer of the 3D design. The platform is lowered, and another layer of metal powder is spread across the platform. The layering and melting process is then repeated until the part is complete. The metallic cover is removed, and a physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditionally made parts. Build times are faster. Engineers can add precise features and complex geometries without increasing cost. In fact, additive manufacturing is revolutionizing the way we work.
Okay, right. Now, if you observe carefully, okay, now I just tell. If you observe carefully, basically what you will be having, this is the work part that you are going to manufacture, that you should manufacture. Okay, right. Now, yeah, okay, now you will be having what is called as a CAD file. So this is the CAD file. Okay, this is the CAD software. Then what is that he is doing? He is slicing. Okay, he is sliced into small things, and that sliced file will be sent to the machine. Okay, so this is the machine, which now layering by layering. Okay, one layer by other layer. Okay, now we use the laser. Now one layer has been built. Then again you just lower it. Okay, it has lowered now. Then one more layer built. Okay, like that, layer by layer you keep on building the material. Okay, so by which you will get the work part. Okay, so this is basically, okay, this is basically called as your additive manufacturing. Now these are all the parts which are going to be which are built by using the additive manufacturing. Only few of the parts that I have shown. Okay, there are plenty of parts which are now nowadays built by using your additive manufacturing methods. Okay, now you can observe this. Okay, the blade. Okay, or the mechanical component, and the medical implantation can also be done by using this additive manufacturing. Okay, right. Now next we'll go further with the basic principles of additive manufacturing. Okay, so please mark this as important question. Okay, from the exam point of view. Okay, in some few of the question paper, this has come into picture. Okay, right. Now what is that? Briefly, I'll just make it out. Okay, now these are the 8 different generic steps which are going to be there for additive manufacturing. Okay, basic principles of additive manufacturing are steps of additive manufacturing process. Okay, first is conceptualization and CAD. Next, conversion to stereolithography. Okay, please observe, STL is what we are going to use. Okay, STL is the word what we are going to use. STL is called a stereolithography. Okay, ST from here and L from here. Okay, is what is called as the stereolithography all about. Okay, right. Now this is the common word. Okay, so ST from here. Okay, and L from here. Okay, is what we are going to call it as STL. Okay, then first is CAD, then conversion to stereolithography, then transfer to additive manufacturing machine and STL file manipulation, then machine setup you are going to do, then you are going to build, then you are going to remove and clean up process, then post processing and application. Okay, these are all the 8 steps which are going to be present. Okay, so right from here. Okay, now you can just observe these are all the steps which are going to be present. Okay, 1, 2, 3 up till like here. Okay, right. Now we'll just discuss one by one clearly. Okay, right. Now, in case of your step 1, okay, which is called as the computer aided design. Okay, that is 3-dimensional data is going to be there. Okay, so now all AM parts must start from a software model. Okay, that fully describes the external geometry. Okay, very important. Okay, now what you are going to manufacture? Okay, you are going to manufacture, let's say, a gear. Okay, you should have what? Okay, you should have the 3-dimensional specification of a gear with you. Okay, that is, you should have made the CAD drawing, okay, of the object by having a 3-dimensional data. Okay, that is very important. Okay, now all AM parts must start from a software model that fully describes the external geometry. Okay, because why is maintaining measurement is fully describes. Okay, because whatever you are going to do the CAD geometry, that only will be sent to the machine for the purpose of production. Therefore, whatever you are going to describe here is very important. You should describe the exact external geometry of the work part. Okay, now this can involve the use of almost any fractional CAD modeling software. Okay, Now you can use any CAD modeling software. Anything is okay. CATIA may be okay. SolidWorks is also fine. Creo is also fine. Okay. Hyper this is also fine. Anything, any CAD 3D software is going to serve the purpose. Okay. This is as general as the one what you are done in your third semester CAMD. That is the first thing. Okay. But it must be a 3D solid or surface representation. Okay. You should be able to show all that. Okay. Right. So this is one thing. Now, one more thing is very important. Reverse engineering equipment can also be used to create this representation. Okay, what is this? What is reverse engineering equipment? Why I am using this reverse engineering equipment? Can anybody say? Why I have to use reverse engineering equipment? I am having CAD. Okay, I am having a CAD software. Okay, I am having a specification. I am going to draw the CAD software. Okay, why the reverse engineering equipment is required? Any idea? Why reverse engineering equipment is required? Right. Okay. Now, please observe. Are you all here? Are you all listening?
Yes, sir.
Yes, sir.
Okay. Right. Okay. Now the question is why? Sorry. Okay. Why the yeah? Why reverse engineering equipment is required is the question. Okay. Now just observe a situation like this. Okay. So you can draw the CAD file, you can draw the CAD drawing only if we have what? Only if you have a specification. Okay, correct, right? What? Okay, if you have a specification, okay, you can write, correct or what? Okay, if you have a specification, okay, you can build the work part. Okay, the question now is, you don't have any specification now. Okay, what you have only the part. Okay, you have only the part, something like this. Okay, right, you have only part is going to be there. Now, what are you going to do with this part is the question. Okay. Whenever you are going to have a part, okay, something like this, just assume, okay, some diagram is going to be something like this. Okay. I don't have the specification of this part. Okay. But I am having a physical part with me. Okay. So when I am having a physical part, okay, I want the data. Okay. Now, please understand, I have a physical part, but I don't have a dimensions for this. Okay. I don't have any dimensions for this. So your additive manufacturing starts from the dimension, not from the part. Correct? Okay. Right? Are you understanding? Your additive manufacturing starts from the CAD data rather than the work part. Therefore, what you do is you use a reverse engineering now. What do you mean by reverse engineering? You have a work part, then from the work part, you come back, okay, so as to get what? So as to get the dimensions. Okay, what is the dimension of this? Okay, what is the dimension of this? I hope you're understanding. Okay, so I want the dimensions now. Okay, if I want the dimensions, how are you going to do? I want to scan. Okay, I want to scan the work part. The simple thing that you have learned just previously is what is called as your CMM. Okay, what you do is you take the CMM. You go here, you measure the dimension XYZ. Then you go to all the salient points. Okay, hope you're understanding. Okay, you go take the CMM probe to all the salient point of the work part and get the XYZ coordinate of all the work parts. Then you will get what is called as a specification. Now this process is called as reverse engineering. When reverse engineering is going to be required, reverse engineering is required whenever you don't have any dimensional data of that particular work part. Okay, if you don't have any dimensional data of the work part, then you have to go by a method called as reverse engineering. Okay, so from the work part you try to get the dimensions. Okay, now for that the examples are going to be laser scanning can be used, or CMM can also be used to create this representation. Okay, so that is what is called as CAD. So in the first step, either two ways. One is directly you have a specification, so by using specification or the dimensions, you are going to build you are going to draw a 3D of a part. Okay, that is one thing. Okay, the second one is you don't have 3D data, but you have a work part. Okay, therefore you use a reverse engineering methodology to get the dimensions of that. Okay, now you have the CAD file. Now once you have CAD file, then what is that you are going to do the second stage? Okay, second stage is conversion to STL. Okay, STL is called as stereolithography. Okay, so the additive manufacturing machine, all additive manufacturing machine will only accept what is called as .stl file. Okay, so your the CAD drawings are going to be in .dxt, okay, something like that, okay, right? But this accept what is called .stl file. Now, conversion to STL, nearly every AM machine, okay, every AM machine accepts the STL file format, okay. So .stl is the code that we are going to use, which has become a de facto standard, and nearly every CAD system can output such a file format. Okay, now once you have done a CAD system, you can save the drawing whatever you have made by using what is called as a STL file. Okay. Now what this file describes is this file describes the external closed surfaces, okay, of the original CAD model and forms the basis for calculation of slices. Okay, so this is very, very important. This STL file will form the closed surfaces of the CAD model, okay, and forms the basis for calculation of the slices. Slices is nothing but what? If you have what is called as a CAD drawing like this, slice is something like this, okay, dividing the diagram into a small entities, okay, with a certain thicknesses, okay, that is called as a slices. Next, transfer to AM machine and STL file manipulation. Okay. Next is the STL file describing the part must be transferred to the AM machine. Okay, now you have CAD file now. CAD file you have converted into STL file. In the STL file you have divided that CAD file into small pieces. That is the completeness of your STL file. Now that STL file you are going to transfer to the additive manufacturing machine. Okay, right. Here there may be some general manipulation of the file required. Okay, now in the AM machine, some manipulation you are going to done. The transfer to AM machine is done. Then some manipulation is going to done. Okay, with respect to the sizing of the thickness. Okay, now every AM machine is going to build with a certain type of thickness. Okay, like we are telling a specification. Every AM machine will have its own specification. Okay, that is build thickness. So there is something called as a common one called a build thickness. Okay. So depending upon the build thickness, I am going to correct the size of the slice. Okay, right. And then position. Okay, position and the orientation for building. Okay, is it going to be a vertical building or an horizontal one? Okay. So depending upon that, I am going to do certain adjustment within the AM machine. Okay. Then after that, you go with machine setup. Machine setup, the AM machine must be properly set up prior to the build process. Such settings would relate to the build parameters like the material constraint, energy source, layer thickness, timing, etc. Okay, now this machine setup is something related with the adjusting. Okay, adjusting or making your machine ready in order to produce the component. Next is building operation. Okay, now in any of the additive manufacturing, building is going to be an automated one. Okay, building is going to be an automated one. So building the part is mainly an automated process, and the machine can largely carry on without the supervision. Okay, without any supervision, this building is going to occur. Okay, only what is superficial monitoring of the machine needs to take place at this time to ensure no errors. Okay, this problem is just with running out of the material, power, or software glitches. Okay, now only you need to observe this problem. Other than that, the material is going to flow. Okay, there will be a material. Okay, we'll all discuss what type of material later. Just remember, in the machine there is a nozzle. Okay, so there will be a nozzle, something like this. Okay, right, and through this nozzle the material is going to flow. Okay, and this material is going to come here, and it just builds. Okay, then again material comes, then again builds, like this it's going to occur. Okay, right. So every time, okay, it drops. Okay, every time it drops an amount of material which is equivalent to a layer thickness. Okay, now this is a layer thickness what I want to build in single shot. Okay, so that much amount of the material will be dropped out of the nozzle. After this, then again I am going to lower this. Okay, I will lower this. Okay, I will lower the table. Okay, because why I am lowering the table means if you just go on repeating like this, okay, the height is going to be more. That's why I'll just keep on reducing, keep on lowering the table, upon which you will start building the material. Okay, so that's about the build. Then after the build is done, okay, then next is removal. That is very important. Okay, now what is that you have done? You have made one platform. This is very important. There is some work platform is going to be there. Then on the work platform, you have built the material. Okay, not like this, as something like this. Okay, then now what you have to do? You have to separate this and this. Okay, right. That is the process called as a removal. Okay, right. Once the AM machine has completed the build, the parts must be removed. Okay, now this is called as the part. Okay, so this is called as the part. Okay, so this part has to be removed. Okay, so this may require interaction with the machine, which may have safety interlocks to ensure, for example, that the operating temperatures are sufficiently low or that there are no actively moving work part. That means, so once the build is done, there is some amount of temperature is going to be there. You need to make sure that the temperature is going to be reduced enough so that when you are going to build, a proper separation has to be taken place from the part and that of the work table. Okay, so that is called as a removal. Okay, so the process of removal. Then fast processing. Okay, once removed from the machine, parts may require an amount of additional cleaning up before they are ready for use. Okay, so parts may be weak at this stage, or they may have supporting features that must be removed. Okay, so this therefore often requires time and careful experienced manual. Okay, now this is very important. Some post processing is going to be required. Okay, right? So after you build, okay, the part may be weak. Okay, because of what? Because of the wetness. Okay, because of that the liquefaction of that. So you need to allow it for some time. It is as equivalent to your casting. Okay, it is as equivalent to your the casting whatever you are going to do. Okay, in your the production methodology. Okay, right? So that is about the post processing. Last one is the application. Okay, so now the parts is ready now. The parts may be ready to be used. However, they may also require additional treatment before they are acceptable for use. For example, they may require priming and painting to give an acceptable surface texture and finish. Treatments may be laborious and lengthy if the finishing requirements are very demanding. Okay, that means now you took out the work part. Okay, now depending upon the application, okay, you may have to go for some amount of what I say, the aesthetic nature to be given to the work part. Okay, so that this is going to be used for a particular application. Okay, now these are all the 8 parts. Okay, now just to have a thing. First one is called as your what? The conceptualization and CAD. So first you have done what? Okay, done the conceptualization, and that conceptualization you have converted it into CAD file. Then from the CAD file you have converted that CAD file into STL file. Okay. So that STL file has transferred to the additive manufacturing machine. Okay, and some adjustment you are done with STL file to note down the proper thickness. Then you have set up the machine. Then the actual work is here. The actual work is going to be here takes place. That is building the component. Then after you have built, the removal and cleanup process is going to occur. Then post processing. Then you use it for a particular application. Okay, now these are all the basic principles of additive manufacturing, which is very important from the exam point of view. Okay, right. Now, before we go to the processes, we'll just quickly brush through the advantages of additive manufacturing machine. Okay, right. So what are all the advantages of additive manufacturing? Okay, there are plenty. Okay, I just come up with some simple important advantages. Okay, variety is free. Okay, right. Variety is free is nothing but what? If you could able to make the CAD data file, any type of product can be built. Okay, so the variety is free. Variety means any type of variety you can able to build by using your additive manufacturing. Okay, that is what is very important. Okay, right. Then complexity is free. Okay, printing of a complex part costs less than a simple tubes of the same size. Okay, that means even though it is going to be complex, okay, it is going to be easy for us to build the complexity. No need for assembly. Okay, right. So in this generally, okay, the assembly of the components we are not going to use. Okay, then little skill manufacturing. Okay, right. Now this is the another greatest advantage of this. Okay, little skill manufacturing. That means professionals take care of the complicated parts with specific parameters and high-tech applications. Children in the elementary school have created their own figures by use of 3D printing processes. Okay, you might have observed the larger usage of this 3D printing. So little skill is going to be required. Then few constraints. Okay, so few constraints. Okay, so not much of the problem. Okay, by which in the CAD software one can dream anything and design the same and create it with additive manufacturing. What I mean to say is, with a very lesser amount of the constraint, you can able to build the component by using CAD software. Means if you can able to build the component by using your CAD software, that can be definitely produced by using what is called as the additive manufacturing. Okay, so that is very important. Okay, right. So Now these are the thing which are going to be present. Okay, right. Now next, various shades of material. Okay, in the CAD file, the engineers can program parts to have specific colors, and printers can use materials of any color to print them. Okay, now we have the material with the color. Okay, so colored things can also be done. Okay, so colored materials can also be used. Okay, so we have ABS plastic we are going to use, or polypropylenes we are going to use. Okay, so these are all the material we generally use it. Okay, now various shades of the material can be used for this particular purpose. Okay, right. Now next is the lower energy consumption. The amount of the energy consumption is going to be lesser. Okay, then less wastage. Okay, so there is not much of the wastage here, because you are going to build the layer by layer. As you are going to build layer by layer, lesser amount of wastage is going to be present. Okay, then reduced time to market. Okay, now as we are going to use it to use it as a rapid means. Okay, as you are going to use this as a rapid means, the time required for you to give it to the market is going to be lesser. Okay, we can create faster, and we can eliminate the need for expensive and time consuming part tooling. Okay, right. Then innovation, a greater amount of innovation can be achieved by using this. Okay, and next is lightweight, very important. It's very lightweight. Okay, and agility to manufacturing operation. Okay, agility is nothing but fastness. Okay, agility to manufacturing operation. Okay, this additive manufacturing is going to give you a greater amount of agility. Okay, agility to manufacturing operation. It is not slow. Okay, additive manufacturing is not slow basically. So we can able to do it faster. Okay, through this particular method of the additive manufacturing. Okay, so that is called as the case of agility. Okay, right. Then now after understanding about the advantages, we just quickly go through with that of the disadvantages of the additive manufacturing technologies. Okay, production cost is high. Okay, so this is very important. Production cost is high. With the use of techniques other than additive manufacturing, parts can be made faster, and hence the extra time can lead to higher costs. Okay, right. Then discontinuous production process. Okay, now because here the problem is the build size. The builds you can't able to build a very larger component. Okay, so even though there are additive manufacturing methods are going to be there, okay, which is possible for you to build a very larger height, but generally the height that you are going to build is generally lesser. Okay, that is the major disadvantage of your additive manufacturing. Okay, requires post processing. Okay, right. So the surface finish. Okay, the surface finish and dimensional accuracy are of low quality than other manufacturing methods. Okay, now it requires post processing. And one more thing that I just want to add here, production cost is high. Okay, now this why this has comes into picture is, now if you observe your 3D printing, the material used for 3D printing is generally a plastic like material. Okay, so if you are using that type of a material, production cost is not high, but that cannot be directly used. Okay, now what nowadays is we are having the metal 3D printing machines are available. Okay, so metal 3D printing machines are available, titanium 3D printing machines are available, which are going to be very costly. Okay, because you have to use that in a particular application. You can't use the plastic like material in an application. Okay, so that is only for a fun type of the arts. Okay, but if you want to use it for a real application, you have to build by using what is called as the metal 3D printers. Okay, so the metal 3D printers are going to be the larger, costlier. Okay, right. Then slow build rates. Okay, so that is what is important. Slow build rates. Okay, so that is a major thing. Right, slow build rates. Okay, some of the printers will take place at a larger thing. Okay, now the time taken is going to be slow. Okay, so that is the important thing. Okay, right. Considerable effort in application design and setting process parameters. Okay, now this is very important. So more amount of effort has to be given. Okay, so poor mechanical properties and post processing is needed. Okay, now these are the disadvantages. Okay, right. Just give me a minute. Okay, some office fellow is there. Okay, 1 minute. Okay, right. Now these are all the major disadvantages of what is called as the additive manufacturing methods. Okay, right. Then applications of additive manufacturing technologies. Now if you just observe the various applications, the applications are going to be plenty. The applications are You can use it for automotive applications, aerospace, biomedical, consumer goods, space application, healthcare, artistic, and architecture. Means to say, what I am trying to say is, now by using your ready to manufacturing work parts, okay, you can make the work part for to suit all the varieties. Okay, now in biomedical, if you observe, you can use it for the leg implants, or nowadays the dentistry, they're also using it largely. Okay, and healthcare, it is going to be largely used. Okay, and in jewelry industries, okay, in jewelry shops, okay, they are going to use it to observe how the styles, how the design of the ornament is going to come into picture. Okay, so all that you can able to make. Okay, and the toys, nowadays toys, if you are going to observe, all those can be built by using your the 3D printing. It is consumer goods application. Okay, now this is finding a very larger amount of the interest, okay, in case of what is called as the available field. Okay, now this is something related to what is called as your the basic concept of the additive manufacturing. Okay, now what we are discussed now is, okay, about the additive manufacturing, how the additive manufacturing word has come into picture. Okay, so briefly, so additive manufacturing word has come into picture to replace the type of manufacturing. Okay, that means what type of manufacturing is, earlier it was subtractive, now we are replaced it by using additive manufacturing. This is also called as what is called a rapid prototyping. Okay, so rapid prototyping is what we are going to call. Okay, right? And then 3D printing is very commonly used. Okay, commonly used word is called as your 3D printing. Okay, right. Next, okay, so the examples and the basic principles of additive manufacturing. This one again I am telling. Okay, so this is very, very important. Okay, right. Then after that, we have advantages of additive manufacturing. Okay, then we understood some disadvantages and the applications. Okay, now the last slide for today. Okay, so this. Okay, now after understanding about the basics of additive manufacturing, now next is what is called as the additive manufacturing processes. Okay, right. So these are all the processes that we are going to use. Okay, now for you, okay, we will be understanding all these 1, 2, 3, 4, 5, 6, 7. There are totally 7 processes are going to be present. How these processes are going to be classified is based on this. Okay, first of all, additive manufacturing process has been classified based on the type. It is liquid based, solid based, powder based. Okay, are you going to use the liquid, or are you going to use the solid, or are you going to use the powder? Okay, so these are all the materials what you are going to use. Depending upon the type of the material, whether liquid based material, solid based material, or powder based material is the first classification. Now then, if you come to liquid based, then next is molten material, polymerizable. Okay, so molten material if you use, so it is called, the process is called as material extrusion. Okay, the process is called as material extrusion. If it is polymerizable, so we call it as vat polymerization, material jetting. Okay, now for this solid based, bonded object, sheet lamination. Then powder based, we have powder bed fusion, direct energy deposition, binder jetting. Okay, now based on this, these are all the processes. Remember, okay, don't get confused. These are all the name of the processes. Okay, so material extrusion process can be done by using a technology called. Okay, so there are different technologies. Okay, I just name some of the technology. If you are aware of that, the additive manufacturing technologies are going to be, first one is very, very, very largely used, is called a stereolithography. Okay, STL. Okay, STL is predominantly used. Okay, so it is called a stereolithography machine, STL machine. Okay, that is the one which is used. Then there is one more thing called as fused deposition modeling. Okay, that is called as FDM. Okay, so it is called as fused deposition modeling. Okay, so that is one type of technique I am telling. Okay, one type of technology. So that technology is going to be carried out using this type of process. Okay, we will discuss what are all these type of process in the next class. Okay, right. Then we have what is called a selective laser sintering. Okay, so we have what is called as the, just observe. Okay, so we have STL. Okay, right. Okay, then we have what is called as FDM. Okay, just observe. Okay, we have what is called as FDM. Then we have what is called as SLS. Okay, selective laser sintering. Okay, right. Then we have what is called as LOM. Okay, that is layer object manufacturing. Okay, right. Okay, so these are all the different types of technology we are going to use in order to produce the component by using these type of processes. Okay, remember, because these are all the processes which are going to be present. Okay, so these processes will use, okay, will going to be will going to be by using this type of technology. Next class when we are going to come, we'll understand what are all the different processes which are going to be present one by one. Okay, right. So this is with respect to what is called as your the additive manufacturing, okay, and the corresponding technologies. Okay, right. Now now I'm just completing the session now. Okay, so I request all of you to type your USN number in the chat box. Okay, please type your USN number in the chat box. Okay, now we'll try to end after some time. Okay. Now this method generally, okay, is the one which is very commonly used. Okay. Now we have 3D printing machines are also available. Okay. So 3D printing machines are available from small to big. Okay. So that is very important. 3D printing machines are available from small to big. Now we have a material. Okay. Small materials. Okay. That is PLA is going to be there. Okay. And then we have what is called as the ABS plastic is going to be there. Okay. Right. Or PVP material is going to be there. Right, these are the type of material what we are going to generally use, okay, for the purpose of what is called as building. Okay, now nowadays what has happened in the new technology has come, okay, which is called as your the metal 3D printing. Okay, so metal 3D printing means nothing but you are going to pierce the titanium powder, okay, through the nozzle. Okay, and it will just flow, okay, onto the it will go as a building material. Okay, like that it is going to be. So that is being present now, okay, but which is going to be a bit costlier compared with that of the plastic type of material what we are going to use. Okay, so this is something related to the 3D printing, okay, or the additive manufacturing. So next class we'll proceed further. Okay, if everybody have typed your USN number, okay, so we'll just close the session. Okay. So thank you very much for joining. So day after tomorrow, we'll continue with the process. Once we continue with the process, so you are going to get a clear understanding. Okay, right. Okay, so thank you for joining. You can leave the class, okay, and attend the next classes. Okay, so I request again, please all of you attend all the classes. Don't miss the classes. Okay, right. So thank you all.